Okay, so just one housekeeping item before we get into this presentation. I attempted to build this as real world as possible. So the attacks that we're going to go over here are the actual attacks that, as they occurred against the servers or the particular server that we're looking at, and we'll talk a little bit about what that server is as we go on. I essentially copy and pasted those attacks directly from our logs or the other mechanisms that we used into the presentation. But there's one exception that I wanted to talk about for full transparency. So if the attack, and there's a couple slides that have these, had a payload attached to it, I removed that payload and switched it out with a Stargate reference. And it was just an ethical thing. I figured it was probably not a wise idea to have the actual payload addresses being on a public presentation. But that's the only change that's going to occur within this presentation. So me, I am the Director of Informatics and Technology Innovation at the University of Rochester, the Wilmot Cancer Institute. I have roughly 25 years of technical experience, mostly in software architecture and development. I do have a wide range of IT knowledge that comes into play with this presentation between law IT and marketing IT. As a vendor, I've been in consulting. And somewhere around the middle of my career, I stopped the healthcare part of my career, and I went back and got a cybersecurity and risk analysis degree, a bunch of certifications, and I started working in that field as well. So that's sort of how this presentation is informed. So I want to talk a couple slides about the importance of this before we go into the actual attacks. The average cost of a data breach by industry, healthcare is almost double the next industry down, and we'll talk about why that is as we go. Oops. And the amount of data breaches is just increasing exponentially, and it's getting pretty rough out there. So our individual tech stack that we're going to be talking about, we have one internal server and two public-facing servers. One's a cloud. For this presentation, we're going to be focused on that middle one, that public server that has a patient-facing tool on it. In this case, it's a clinical trial application, which we'll go into as well. The development stack, which will come into play as we go through this, as we're looking at what these attacks are. It's a Python Flask-based application that we're mainly looking at, HTML5 and JavaScript, of course, and then the back-end database technology that we're using is Microsoft SQL Server. So I don't have it on here because I wasn't sure if anyone would cringe if I put it, but it's an IIS server as well, given the SQL Server background. The importance of these systems. So we have 200,000 unique patients within our system at Wilmot, which encompasses 10 million plus encounters. So an encounter, for our purposes, is defined as anyone or any interaction with our services. And within this data, we have demographic data, so your sex, race, gender, ethnicity, those types of things. We have your financial data, so we know your insurance company, of course. We know, depending on what services you've had, we might know where you work, as well as your credit card information, all of that kind of stuff. Address information, so we know where you've lived in the past, where you live now, all that geocoded locational stuff. And then, of course, we have the healthcare data, so diagnoses and anything that has gone on in interaction with the system. So if you think about this, and back to the graphs on the other slide, if you're going to hack a bank or if you're going to hack a library or whatever you're going to hack, you might get one or two of these pieces, but healthcare has them all. So I would posit that's also one of the largest reasons that healthcare is getting attacked so much. We also typically have budgets that are constrained, and we should have double the staff and all of that kind of stuff. So it makes for a really nice target. And then on the other side of that, aside from the PHI portions of it, the system that we're going to be looking at is a clinical trial system. So this is connected to the extensive PHI-driven systems, but trial and participation is important for progressing the science and progressing the treatments and all the protocols that are involved with that. So if this system goes down, it's also equally as devastating, or it could be equally as devastating as PHI stolen or anything. So there's multiple aspects to this. Okay, so The numbers for this system, I went through these for this presentation line by line across all of our logs and across everything that we had. And it turned out we have we have 9,384 unique attacks on the system since 5/2021. The reason I chose that date is that's the date that the system went live. That equates to roughly 2% of the total unique users were essentially trying to attack us. The volume of attacks is increasing significantly over time, and some of that could be because as the system became more popular, the attacks increased. But I'd also say, I mean, the healthcare attacks are just increasing significantly. Large-scale attacks also occurred in clusters for whatever reason. There were none from the time that this app went live to pre-October 2022. And then there were 3 after that in October 2022, December 2022, and May. When I was looking at these, this isn't part of this presentation, but I noticed that those large-scale attacks on our infrastructure were 2 weeks before major national attacks. So May 2023 being the Move It attack. So there might be something there for the future, but that was kind of interesting as well, that you could kind of predict those large-scale attacks based after what I assume they're doing recon or something. But again, for this presentation, I didn't go into those. So what is the app that we're going to be looking at and the attacks that we're going to be looking at against it? It's the clinical trials app. It essentially allows you to search by disease or search by any of these parameters on the screen here, as well as type in a search parameter that you're looking for and delve down into your specific diseases, and then it'll show you all the trials that are available to you, as well as allow you to contact us and interact with the clinical trials office in that way. But as a former pen tester, and then eventually I did red teams, the way that I look at this is what's the most likely attack that's going to happen on something like this. The first is the search window stands out to me. You're probably going to get a bunch of ejection attacks, those types of things. And the second is, which you probably can't see it, it's not showing up. There's a bunch of URL parameters on there. So it'll say searched by disease equals breast. And there's reasons that we did that we can talk about later. But and then you might look at the buttons, you might look at other things, but that's what I'm kind of looking at when we're trying to test this site. Okay, so the way that I've broken the rest of this presentation up, these are the actual attacks. These 4 attacks are essentially of the same category, and all the scenarios will be the same. They'll be of the same category. There might be 1 or 2 or 4 like this. I'm curious, does anyone other than my team in the room know what these 4 attacks represent, the name or what this would be? Got it, yes. So SQL injection is the #1 attack that we see. And I'm going to give all the numbers as we go on in the mitigation techniques that we're using to stop this. But these are the most common. So let's talk about what this is. In a normal scenario, if you remember from that front screen, someone should be typing in something that they're looking for. So let's say lung cancer, breast cancer, whatever the case may be. And behind the scenes, it's going to initiate some code, in this case, this query. So another caveat here, this is the actual code that would run, but I've reduced it for this presentation. It's a little bit more complex than this, obviously. But for this purposes, it's going to run select star from Encore Protocols, which is the trial database where the title equals lung cancer. So whatever is put in that search parameter, it's going to put it directly into that code. It doesn't actually work like this. I'll show you how it works in a moment, but that's the general idea of these searches. The associated result then would, in this case, return 2 lung cancer phase 3 trials, and this would be a valid result. So on the front end, you would have it nice and pretty. It would return those 2 results, and everything would work as expected. So if you remember back to that previous screen, one of the attacks, I'm just using this attack because it's the easiest to explain. You saw PG sleep and some other things on there. But if they were to type in this, so single quote or 1 equals single quote 1, in that same exact scenario, what would happen is the sequence would look like this. So where title equals nothing or 1 equals 1. So what they're doing here is invalidating the entire clause that we have. because title equals nothing is never going to be true in our system, but or 1 equals 1 will always be true. So it wipes out the whole line, and you essentially get an entire database dump from select star from Encore protocols. So that's what they're trying to do. It didn't work like that, and I'll explain why. But if they were to have gotten that entire table dump, they would have gotten everything within our database. I mean, doesn't quite, because we have all sorts of mitigating attempts on this, but that's what they're trying to do, and then you'd have access to anything that we had in there. So by the numbers, SQL injection represents 33% of all attacks globally. The most known, I mean, this is the most common, so there were too many to account, so I just listed Sony and Drupal and multiple .gov attacks. But within our system, this represented 3,825 of the roughly 9,000 attacks that we had, or roughly 39%. It's a little bit higher than the global average, but that's probably within reason. I broke those down further since I had looked at them line by line. 59% of them were TSQL or MySQL-based attacks. I understand that for anyone who knows code, they're syntactically different, but from this perspective, there would be no way for me to know which one they were trying to do. There is ways for Postgres, so PG Sleep is only used for them. That represented 21%, and then Oracle or something else represented 20%. It's sort of hard to classify some of those 750 because they could have been anything, or broken for that matter. The other thing that I would note with this too is if you remember that tech stack, and we'll talk about this at the end, very few people were performing real recon because they would have known not to use some of these attacks against us because they just wouldn't work. We don't use those systems. Mitigation-wise.
Do you have to authenticate to the system to deal with the query, or is it?
Not for that one, no. Yeah, the search box will let you go. Mitigation-wise, we mitigate by the most common SQL injection mitigation is prepared statements and parameterized queries. So the idea being that whatever the user enters in, we don't run directly. We separate the running of those. We also escape user input, so you can't just type in anything that you want. Least privileges on the app account, you'll see a lot of these. This particular web app doesn't allow for write access. It only allows for read access. You can't just navigate to any folder. You can't do certain things, which also come into play in future attacks here. Whitelist where possible. In this case, SQL injection is not really going to be helpful for this particular app. But error handling, prevention, and information leakage, and extensive security testing and review are going to be on most of these. And we'll talk a little bit about what that means as we get to the end here. So this is attack scenario 2. All 3 of these are also of essentially the same variety. I'm curious, I'm going to be jumping around. They're not all going to be, I guess, easy, but does anyone know what this grouping is? Or represents, at least? Except for my team. Oh, you can't see it. I'm sorry. Oh, yeah. Got it. All right. So these are XSS attacks, and like I had mentioned at the start, the payloads are changed to Stargate references, just full. But otherwise, these are the actual attacks that occurred. Okay. So in a normal scenario for XSS, what you're looking at is some piece of code that's running. In this case, we're looking at the UR Wilmot logo from the source in that folder structure, that static assets, and then logo WCI. But when we get to the attempt, this looks like the third one, that image src equals to X is never going to be true because we don't have a folder called X, and that's not even a proper folder structure anyway. So it would always fire that JavaScript on error equals and then append child and then the Stargate payload, I guess, in which case it would load that payload. I'm showing an image here, but what they were actually doing was loading malicious code to our site so that anyone that was accessing the site would have loaded their code instead of ours. Or I guess you could deface the website in the way that I've done here with a Stargate logo. One of the other mentions that I would do with this particular thing, for anyone who knows code here, that code actually wouldn't work. And I realized this when I was talking to the team and running through this a couple days ago. This is a common theme. If they're using scripts or if they're manually doing this, I don't know, but as a developer and architect, I know that code is incorrect. You would have to do document.appendchild and those types of things. So this happens a lot with them. I mean, so even if we were vulnerable, it wouldn't have worked because the code's incorrect. Yeah. So globally, XSS or cross-site scripting attacks represent 25%. For us, it was a little less at 22% or 2,106 attacks. I did the most known as Sammy Worm. It might not be the most known anymore, actually. I just like that attack. For anyone old enough, that's the MySpace hack. The breakdown of the XSS attacks are interesting too. You can see them there with their examples, basic scripting, DOM-based, all makes sense. HTML events. One thing that I noted was these base 64 image embeds. So it has been a while since I've pen tested anything. I've never seen, I don't know why that's 7%. Like, I don't know what they're trying to do with this. Obviously it didn't work, but that's fascinating to me. I mean, maybe there's more attacks that I know about, but there were a lot of those. And then other.
Things can actually store code within them to do things, so that's probably why.
Well, that makes sense. I hadn't seen those a lot when I was in the security realm. And then other 23%, that's so high because it's really hard for me to classify some of these attacks because of the way that they're written. Some of the code is wrong. Some might look like, I can tell they're XSS, but I can't really tell what they're trying to do. So for our mitigation techniques, we have strict CSP policies. We have output encoding, so less than, greater than versus the @LT. We have 30 or 40 apps internally, but externally we don't do a lot of public apps. But when we do, we classify those as very different, and the manner in which we test them is completely different. Escaping user input again, of course, and then HTTP only cookies to prevent session cookie thefts, and then the last two, which are on pretty much all of these that we'll get to at the end here. So now it's going to get a little bit more difficult or interesting. Maybe not for you all, I don't know. Does anyone know what this attack represents?
It's related to the log4j, isn't it?
Someone got it. Yeah, but you're right too. It's log4j, the JNDI attack. All right, so log4j, at least in our context, is really hard for me to actually show and describe what this is doing, because you would never in our app run or reference this Java within the app. It would always be behind the scenes. It would always be something like that. So I'm going to try to do the best I can with this explanation. But let's say you were to actually do this hard-coded in the background and initiate an LDAP request against example.com. You would be returned with common name, a UID, email address, and so on, which is also why we don't do this on the web app, because that would be not great. But in the unprotected scenario, what it's doing is masking that out to, and then loading the Stargate payload. And again, I'm just defacing the website, but this would be loading something malicious every time that someone had entered. That attack globally, it was 840,000 log4j attacks in 2021. 8% of the Maven repository, or 35,000 Java packages, were affected. The most known, I think, of that was the Department of Treasury, although there were several. In our system, I tried to trick you all, but you both got it. But this only represents 64 of the attempts, or 0.7%. It's still interesting that they're trying it on us. They're not doing it often, but a lot of these look like they were manually typed or something because they were way too specific. That one was the most basic that I had showed you. For log4j, there wasn't, I mean, there's not much you can do. I mean, proper timely and patching, I mean, we all knew there were publications all over the place for this. Monitoring and alerting for sure, and we have least privileges on the app. It wouldn't have worked either, even if we don't allow any JDNI interaction. Okay, so this attack is a lot more common actually, but does anyone know what this is? Yeah. So URL traversal attacking. In this case, this is a Python Flask-based app, so I'm taking some liberties here as well with describing this because obviously the search window doesn't look exactly like this, but this is the actual address. So if you were to type in this address, you would be going into the search by disease screen within our app, which would go to this file structure out in IIS and look up for the file, load this file and show the user this particular set of code. In the attempt, for anyone who doesn't know what the URL traversal language is, that // means essentially go back a folder. So they're trying to, I think there's 15 there. They're trying to go back 15 folders and then forward to this path directory here. What they're trying to get to is this file, the var www html etc password file. And again, we're IIS, so I don't know what there's obviously no recon going on here because they wouldn't have tried this if they had known that because this doesn't exist in our system. But if they did get to that, what they would be returned is something like this with the user credentials, and that's what they're trying to get at least. Again, IIS, so that's not going to work either way. Okay, so globally, URL traversals weren't listed in the OWASP top 10. I couldn't find any information like the other ones with how many the attacks those represent globally for whatever reason. The most known is the Sony Pictures hack. That usually URL traversals are part of more sophisticated attacks, though. So it wouldn't just be this; it would be other things involved if it worked. In our system, though, we did have 368 attempts, unique attempts for this, which is roughly 4% of our of all of the 9,000. And 344 were looking at that password file, or 94%. The other 24, I don't even know what people were doing. They're like super old Windows 3.1 methodologies and just weird things. So I'm not really sure how to classify those, but most of them were looking at that var www file. So the mitigation techniques that we're using, we use input validation like we do with everything else, with all the other attacks that you've seen here. One of the bigger things that we do is we don't allow user input for file manipulation. So some of our systems allow file uploads for various reasons. We code those with an ID instead of the actual directories. There's a funding opportunities page and all these other things that use this logic, which is actually the image you're seeing here, if you can actually see it. We also have least privileges on the web app. That app doesn't actually have access to go to any of these other database structures, or file structures or anything like that. So there's nothing that we're going to be able to do with those anyway. And then the two that are on all of these, monitoring, logging, and extensive security testing and reviews. Okay, so this one's interesting too. The name is it's sort of in the name, so it's kind of cheating. But anyone know what this is, by chance? Okay, so it's considered I think it's just actually named CRLF injection, which is what I named it. At least that's all the literature I can find. Carriage return line feed, so it just means going down a line. What they're trying to do with this is, in a normal scenario, if you had a parameterized web address like you're seeing here, in this case, we're logging the name equals John. The result, the website that would return, it would return something like hello John or whatever it is that you're doing. In our case, we're using it for logging and other things. In the CRLF example, what they're trying to do is there's two different things. This one's a little bit challenging to describe what they were trying to do because I'm not quite sure based after what they typed in, but it could be either HTTP splitting or cookie injection. So the first one that we're showing you here is HTTP splitting. It's if you see in that, it's actually probably really hard to see in there, but you're taking the welcome John and then you're carriage returning another location to load. So in this case, I loaded the Stargate malicious site. You can also do this with cookies if it's not protected, setting a cookie with a malicious session ID in this manner. And that is exactly what happened with the Equifax data breach. It was essentially this attack. Globally, again, I couldn't find any numbers that were pretty solid for how many of these encompass, but 147 million people were exposed in that Equifax data breach. Our system, this is another tricky one. It represented 40 of the attempts, so there were quite a few, I guess, not in relation to that 9,000 though that we had there. So that's roughly 0.5% of them. And there were those 40 actually were pretty varied in how they were doing it, but none of them would have worked. And the reason is we validate and sanitize that input, so we don't allow CRLF characters, the \r/\n on the web server or anything itself. We never allow HTTP headers to be directly manipulated, and log monitoring and security testing is on this as well as most of them. Okay, so a couple miscellaneous attacks. Now, I'm not going to ask what these are because I didn't know what they were. The first one, I'm assuming, is some kind of broken LDAP attack, just because it says object class. We see this a lot with those 9,300 whatever attacks there were. They either mistyped or their script that they were running failed, or I don't know what the case is, but I'm assuming that's some kind of broken LDAP attack. The second one I'm assuming is some kind of XML external entity attack. Again, I'm not quite sure because it wouldn't quite work. But I guess the point is, if you add up the attacks that we've seen so far, I think you roughly get to 60% of them. But the other 40%, the reason there's so many is I don't know what they are. They look like stuff like this, or this is just all over the place, which we're going to talk about at the end here. So some additional notes about those previous 5 attacks. Internally within our system, all of our software is custom coded. This is making it a little bit more difficult to attack. We don't use WordPress or any of those management systems. Everything we're doing is custom coded. So since people clearly aren't doing recon, it's affecting them in how they're attacking us. We are essentially a research and development team. We're not a fully security team or anything like that. So we custom code everything, which does increase technical debt, of course, but kind of helps to protect. We have constant monitoring and monthly reports on all of these public apps. There's an individual that is very good at finding things very quickly that look odd on these apps, which helps quite a bit. And then we pen test all of our public-facing apps, which is rare for healthcare. So I don't know what it's like in industry. In healthcare, generally, you wouldn't have the expertise to do this. Generally, you wouldn't be custom coding either. The team's kind of unique. But you have me, and then there's another individual on the team that teaches at a local college and stuff like that. So we have the ability to do these things. We've also started pen testing internal apps too, but certainly the external apps are pen tested. We extremely limit our Python libraries, so for the same reason that we don't use WordPress, we're limiting to only what we exactly need, which helps reduce your vector. Our servers are completely separated and isolated, so a lot of people would cringe at this too. It raises technical debt, also costs a little bit more, but every single web public-facing app that we have goes on another server, which sounds outrageous, but the cost of these servers aren't high for us because they're not. We might get 10,000 users a month or whatever, so they don't have to be really powerful. We also separate the databases on all of these servers. Everything is separated, so if one thing gets hit, nothing else is going to get hurt. And then we don't allow the bidirectional functionality back to our internal system. So the internal system has that 200,000 plus 10 million encounter, unique patients and all that kind of stuff. The public systems aren't allowed to go back to it. We only push data to the public servers. Some additional offensive notes that I kept alluding to. So The hackers are often obviously not doing recon. Given the tech stack that we have, most of these attacks wouldn't have worked. Well, half of them wouldn't have worked. There doesn't seem to be any recon on if this is IAS. I mean, there's so many easy ways to eliminate most of these attacks that they were trying. You could, just understanding what the systems were built with would have helped them not do some of them. Same with the database technology and like Linux and versus anything. But the code was often mistyped on the manual attempts as well. So I could tell when people didn't really understand programming concepts like that XSS attack that I had showed you that was missing the document dot. This happens quite a bit as well, which I was surprised about because I was assuming they would just be using scripts or something along those lines, but maybe the scripts have it wrong. And then the hack of the day attempts, Log4j clearly wasn't going to work, but people are trying them. Obviously not that much. I think there were 60 of them or whatever there were. The majority of the attempts were obviously scripted or copy and pasted into this web app through whatever means that they were using. The last thing that I noticed with a lot of these attacks were these kitchen sink attempts, which I have no idea, and maybe you all do. I mean, this is attempting 4 or 5 different attacks all in one. There's just no way this would work. You'd have to have the most catastrophic security condition ever, I would assume, for this to work. Either way, it wasn't going to work because we're just not vulnerable to 500 different attempts within one single parameter. And then that's pretty much it. Does anyone have any questions on any of that? Yes. So our group is research and development. The university as a whole does have an actual security group that. So there's a couple layers in there.
Do you have a logging service that generates these events and it gets to you in some easy fashion, or you have to go digging for it?
We custom coded it all. So we have a logging service that's custom coded that brings it all to us automatically, and then we do manually look at these as well. But the code that we built logs everything that everyone is doing all the time, and then we can see it from there.
You guys are doing it, it's not going to the
No,
SOC and they're giving you a report.
no. Yeah. Okay. Yeah.
Thank you, Eric.
Thank you.